Welcome to another interesting video on our Be Aware channel. Hope you all are good. Welcome to another tutorial, that is tutorial 2. If you haven't watched our tutorial 1, do watch it. It is available on our channel. So in this tutorial 2, what you are able to see on your screen is the problem statement for that particular tutorial which we are going to perform today. In this today's tutorial, we have considered one of the company named as ABC, and it is having a part named I304, and we are going to analyze the production capacity for I304 and the issues in a line if we have any, and we are going to bring in the recommendation for that. So we are going to model this in our Flexsim model. So this is the problem statement. So the part I304 is formed by three different components A1, A2, A3, in which A2 is assembled after assembly of A1 and A3. That is, A1 and A3 forms A2, and the cycle time for forming, combining A1 and A3 is 5 minutes, while the assembly of A2 requires 10 minutes. Okay, and the line is down for breaks of 30 minutes lunch break and runs for one shift of 8 hours per day. So this is the problem statement. We are going to model it in our Flexsim background. Then what are the tasks we are going to do? So we are going to create a model for the scenario. We are going to find out the solution recommendations if the demand is not possible to achieve. So what is our demand? It's 90 parts per day. Then we are going to create the dashboard for station utilization and throughput per day. So what are learnings we are going to learn from this? So we are going to have modeling steps done. We are going to learn dashboard creations and debugging it. We are going to learn analysis of whatever we are going to work on. And we are going to learn how to apply the breaks in the timetables using timetables, because we haven't covered this on our channel yet. So we will be having it a flavor. So already covered in tutorial 1. Again, we are going to cover it in our tutorial 2. So let's begin without wasting much time in our Flexsim modeling. So welcome to the Flexsim model background, and now we are going to start modeling as per our problem statement. So it has been told that we have three parts named A1. Okay, so the AM is going to be for 1 second interval time. Then another also 1 second, and we're going to name this as A2, and then third source as A3, and we are going to make it as arrival at 1 second. So we have these three sources made. The problem statement was told that the part which is going to be formed after combination of A1 and A3 is going to then get combined with A2. So we are just bringing in the combiner, and it is told that the process time for this A1 and A3 combination, that is assembly cell, is going to be 5 minutes. So I have assigned 5 minutes to it. I'll rename this assembly 1, and then what we are going to do is ahead we are going to have another combiner which is then going to have the combination done with the help of the part generated in A2, and then we are going to have a buffer here. So here I'm going to rename it as assembly 2, and the process time which is given is 10 minutes. So I have assigned here as 10 minutes, and now the line is down for breaks of 30 minutes, it is told. So our line, if it is going to be down for 30 minutes of breaks, and we are going to run it for one shift, we are going in the table, we'll make it as weekly repeat, and as we are going to run only one shift, what we will be doing is we'll drag it till 6, and then we'll close it at 14. Correct? It's how many? Like from 6 plus 8, it's 14. And now what we are going to do is we are going to replicate it above. So here I have replicated this, here I have replicated this. I'll make this apply, I'll make this okay. Now we forget it applying again. So what we are going to do is the members we are going to select it now only. So assembly 1 and 2 will go in the breaks and shift down. Also it was told that we need to have 30 minutes of break time. So we are going to assign it from 11 to 11:30, and we are going to have it all the days. So I'm going to just save it. So we have applied breaks, we have applied shift timings. Now we need to have a buffer in between assembly 1 and assembly 2. The reason is we are going to have this station assembly 1 will be faster because the cycle time is only 5 minutes and the speed is slower, it is 10 minutes. So I'll just have a buffer in between and I'm going to connect this again to the assembly station 2 and we'll just reset. Now we'll go in the dashboards and we'll just analyze the states for the stations. We'll prepare station graphs. So what I'm going to do is I'm selecting assembly 1, assembly 2, so we'll get the state-wise analysis for these two. And then we will go in the output per hour graph, and what we are going to do is we are going to make it as per day, and we are going to rename this as day, and we are going to bring it as this Q1. In this Q1 we are going to connect it to the sink, because if we are not going to connect the sink, we are not going to have a throughput done. So now we are going to just reset and run, and we are going to check what is our throughput going to come. So I'll just reset again. We need to start it at 6 because our shift starts at 6. We are going to bring it at 3rd of Monday. We are going to stop it after 3 days of run. Hopefully we are not requiring a warm-up time here because nothing seems to be that bulky as it was in our tutorial 1 if you have watched. So I'll just run this. So I'm running it and I'm running it and I'm running it, and I'll just check once it comes to the stopped state. And if you look at what we are having is we are having 44.50. That is approximately we are having half of the capacity, that is 90 parts per day. Currently we are having almost 45 parts per day. We require 90 parts per day. That is almost, we need to have a double. We need to have a double thing. Now if you look at this, the buffer is highly filled, but the buffer cannot be utilized because the assembly 2 is the slower station. So ultimately this acts as the bottleneck for the system. Now what we are going to do is we are going to add one more additional station here, which will be our assembly station 3, and we will also move the parts to these of the assembly stations, come to the Q1 again. So we have assembly 2, assembly 3. Already it has came in the state graphs. Now we'll just reset and we will run. So if you look at this, assembly 2 is 100% utilized, 3 is 90 and 89% utilized, and the station is 100% utilized. So now if you look at, we are having 88.50 parts, so we have almost came very close to 90 parts per day. Slowly if I run it for a couple of minutes ahead, it will go to 90 because it is just a start of shift, 6 o'clock a day, and hence it is supposed to go to 90. So it is here at 90. So this is all about our problem statement. We have fully fulfilled this problem statement, coming to where we are getting 90 parts per day with the stations utilizations seen here. So for ABC company, we have solved the issue with a recommendation to add one more assembly station for assembly of A2 part, so that we can form I30 part with 90 parts per day as your line capacity. So this is our solution and recommendation for ABC company. So if you haven't liked and shared this video yet, do like and share this video. If you haven't subscribed to our channel, do subscribe to our channel. We will meet in another interesting video with tutorial 3. Till then, take care, stay safe, stay tuned, stay simulating. Bye bye.